Feature engineering is one of the core techniques that you can use to increase the chances of success when you attempt to solve various machine learning problems. The main purpose of feature engineering is to help increase the power of machine learning algorithms. It does this by using the values of existing features to derive new features, new values that might prove more helpful to the model during the training process. And to help you better understand this, let me give you a very simple example. Say you have a data set about customer behavior. Here's an interesting question. What is more relevant to predict future behavior for that customer? The number of purchases during the last month, the number of purchases during the last 3 months, the average number of purchases during the last 6 months, the number of purchases during the last month compared to the number of purchases performed in the month before. You can already see that there are multiple variations that all are tied to the same original information, which is the number of purchases a customer does. This is where feature engineering helps us to derive these features that are better suited for certain types of machine learning algorithms. And the main reason why we discuss feature engineering like on its own, separately from other common types of tasks in data preparation, is because feature engineering is perhaps the most important one of those tasks, as it lays the foundation for good models with good capabilities in terms of prediction and stability. It is also important for you to note that feature engineering is not always necessary. There are cases where the existing features are just fine and you can train your model and you can get a good model just by using those features. Now, from the point of view of where does the feature engineering process occur, there are actually various places where that happens. For example, you can do feature engineering right at the data source. Think about, for example, your data source being a relational database. There are a number of new features that you can calculate using the capabilities of the underlying database engine, which can be actually calculated in a very performant way because the database engine supports those types of calculations. So it makes a lot of sense to do it over there. But also, if you have like more elaborate processes, for example, you need to apply some libraries, some types of complex data calculation processes that are implemented, say, in Python libraries, then it makes a lot of sense to run your feature engineering process within a Python environment. And if you are, for example, working with very large amounts of data, maybe even streaming data, then it makes a lot of sense to do that in like a streaming environment that supports parallel data processing like Spark. Also, the feature engineering process can be performed in a dedicated environment, and the example I just gave you, the Spark environment, is the best example for that. Finally, the third place where you will typically see feature engineering happening is during the very process of training your model. It is not uncommon to derive new features as part of the training process itself. Finally, there is an important distinction here to be made between the way classical machine learning approaches feature engineering and how deep learning does it. Well, with classical machine learning, feature engineering is typically an explicit kind of process. You need to explicitly create the new features that will be used by machine learning models. With deep learning, most of these feature engineering occurs kind of naturally within the neural network itself, so it's not uncommon to defer feature engineering for the training process itself. And also, deep learning can be used for the implementation of certain feature engineering processes, like, for example, embedding, which we will discuss a little bit later.